Let's discuss this determinant question, and the question was pretty easy one, and it's that Dn be the determinant of the n cross n matrix whose entries from left to right and then top to bottom are cos 1, cos 2, cos 3 up to cos n square. Like this is the structure of Dn determinant. Like we are starting from cos 1, cos 2, cos 3, continues up to cos n, then cos n plus 1, n plus 2, n plus 3 in this way, and finally, since it is n cross n, so final element is cos n square. So we need to find out that the limiting value of Dn when n tends to infinity. Now if we closely inspect the determinant Dn, and if we apply a column transformation, like if I apply the transformation C1 changes to C1 plus C3, if I apply this transformation, that is we are basically interested about this column 1 and this column 3. So we are changing C1 to C1 plus C3, then this particular element cos 1, that cos 1 will be modified to cos 1 plus cos 3, then cos n plus 1 will be modified to cos n plus 1 plus cos n plus 3, and this particular element cos n square minus n plus 1, that will be modified to cos n square minus n plus 1 plus cos n square minus n plus 3. Okay, by applying the transformation C1 changes to C1 plus C3. So let's see that if we do these transformations like cos 1 plus cos 3, so basically it is going to be equal to so if you go back to our initial configuration, so the first element will be cos 1 plus cos 3, so applying transformation formula we can write down, we know cos c plus cos d is 2 cos c plus d by 2 and cos c minus d by 2, so it is going to be 2 cos 2 cos 1. Then this particular element will be deleted and this will be replaced by 2 cos n plus 2 cos 1, and in this way the final element is going to be replaced by 2 cos n square minus n plus 2 cos 1. So ultimately you can see that the entire column 1 will be proportional to column 2, right? Because column 1 is basically multiple of column 2. Like this cos 1 is basically getting multiplied with every element of column 2 in the first column. So we can say that now C1 is proportional to C2, and since C1 is proportional to C2, so we can safely claim that the determinant Dn is going to be equal to 0, and so the limiting value is also equal to 0. So 0 is going to be the answer.